All right, so buckle up, everybody, because today we are diving headfirst into the quantum realm.
Whoa, sounds intense.
It is, kinda. We're tackling a concept that's got everyone buzzing. Quantum supremacy.
Yeah, that's a big one. Where are we starting with this?
Well, our main source today is a fascinating article by Jurgo Schneeppert.
Okay, I know Schneeppert's work. He always brings up such thought-provoking questions.
Exactly. His article is titled Quantenüberlegenheit, der Durchbruch in der Rechenleistung.
Ah, so it's in German.
It is. But don't worry, we'll break it all down in plain English for you. No need to dust off those German dictionaries.
Ew, good to hear. So what exactly are we trying to unravel today?
Well, I think a lot of people hear quantum supremacy and their eyes kind of glaze over.
Yeah, it can sound pretty intimidating.
Right. So today, we're on a mission to demystify it. We want to figure out what it actually means, why it matters, and what Jurgo Schneeppert thinks about its potential impact.
Sounds like a plan.
So let's start with the basics. When we say quantum supremacy, what are we actually talking about?
Okay, so the term was coined by physicist John Preskill back in 2012, and it basically boils down to this. Quantum supremacy is achieved when a quantum computer can solve a specific problem much faster than even the most powerful classical supercomputer.
So it's all about speed, like a quantum drag race.
Sort of, but there's a nuance here. Schneeppert's really emphasizing that it's about outperforming classical computers on a specific task.
Okay, why is that distinction so important?
Because quantum computers aren't meant to replace the computers we use every day. You know, they're not going to be browsing the internet or writing emails anytime soon.
So no quantum smartphones in our future.
Probably not, but they're designed to tackle specific types of problems. You know, those that involve really complex calculations and simulations that would take classical computers an insane amount of time to solve. We're talking thousands of years, maybe even longer.
Okay, that makes sense. So it's more about specializing in certain very complex tasks. But how do they do that? What makes quantum computers so different?
Right, so Schneeppert really dives into two key concepts: superposition and entanglement.
Those words always sound so mysterious and sci-fi. Can you break them down for us, mere mortals?
Sure. Let's start with superposition. Imagine a regular computer bit. It can be either a 0 or a 1, right?
Right, that's the basic building block of all our digital stuff.
Exactly. Now, a qubit, which is the quantum equivalent, can be both 0 and 1 at the same time. It's kind of like, think of a coin spinning in the air before it lands. It's both heads and tails at the same time.
Whoa, okay, my brain's starting to hurt a little.
That's superposition. And that's what gives quantum computers a massive speed advantage for certain problems, because they can explore many possibilities simultaneously.
Okay, so that's pretty wild. But then there's entanglement. Now, that one I think really trips people up.
Yeah.
And it seems like Schneeppert finds this concept especially interesting.
Oh yeah, entanglement is definitely one of the weirdest, most mind-boggling things in quantum mechanics. It's like, imagine two gloves, one left and one right, separated by a huge distance.
Okay, I'm picturing it.
Now, if you discover one glove is left-handed, you instantly know the other one is right-handed, right?
Yeah, that's just logic.
Exactly. Well, entangled qubits are kind of similar. Knowing the state of one instantly tells you the state of the other, even if they're miles apart. It's like they're communicating instantaneously, which is, well, bizarre.
That's insane. It almost feels like magic. So has anyone actually achieved this quantum supremacy thing that Schneeppert's talking about?
Yeah, they have. Back in 2019, Google made a pretty big splash when they claimed that their quantum processor, Sycamore, did a calculation in just 200 seconds that would have taken a classical supercomputer about 10,000 years.
Wait, 10,000 years versus 200 seconds? That's mind-blowing.
Yeah.
But what was this calculation actually doing? Like, what was the point?
Well, that's where things get a bit more complicated. Google designed a very specific problem for Sycamore to solve, one that really played to the strengths of a quantum computer. It wasn't something with immediate real-world applications. It was more like a demonstration of what quantum computers could potentially do.
Ah, okay. So it was more about showing off the potential rather than solving a practical problem. But Schneeppert mentions some controversy surrounding Google's claim, right?
Right. Some critics argued that the test was too contrived. You know, it was specifically designed to show a quantum advantage and didn't really prove anything about how useful quantum computing would be for solving actual real-world problems. Some even claimed that a classical computer could have done the same task much faster than Google estimated if it had been programmed differently.
So while Google's achievement was a big deal, it wasn't quite the quantum revolution some people made it out to be.
Yeah, I think that's a fair assessment. It was more like a proof of concept, a glimpse into what might be possible. But there's still a long way to go before this technology is ready for prime time.
Okay, so let's talk about the potential benefits then. What could quantum supremacy actually do for us?
Well, I think Schneepat does a great job of outlining some of the possibilities in his article. One of the most promising areas is medicine. Imagine quantum computers simulating complex molecular interactions.
Oh, what?
Right. This could lead to the development of totally new, life-saving drugs and therapies.
Yeah, that would be incredible. Especially because drug development is so slow and expensive right now.
Exactly. And it's not just medicine. Schneepat also talks about materials science. Quantum computers could help us design completely new materials with properties we can only dream of right now. This could revolutionize everything from energy to transportation to manufacturing.
This is starting to sound like something straight out of a science fiction movie. But like with any powerful technology, there are also potential risks, right? Schneepat spends some time on the topic of cryptography, for example.
Yeah, that's a big one. Quantum computers pose a real challenge to how we keep our data secure. Many of the encryption methods we use every day to protect our information could be broken by a powerful enough quantum computer.
So, is all our data at risk? Are our online secrets about to spill out?
Well, it's not an immediate threat, but it is a serious concern that we need to address. Thankfully, Schneepat mentions that researchers are already working on quantum-safe encryption methods that are designed to be resistant to attacks from both classical and quantum computers.
That's reassuring. So it seems like quantum supremacy is a bit of a double-edged sword. It brings incredible opportunities, but also some serious challenges.
Yeah, I think that's a good way to put it. And Schneepat really urges us to carefully consider both the potential and the pitfalls as this technology continues to develop. It's not just about the science, but also about the impact it will have on our lives.
I'm definitely feeling a lot more quantum savvy after this conversation. What else does Schneepat want us to think about?
Well, we've talked about the potential and the excitement, but there are still some big technical hurdles and limitations that we haven't really touched on yet.
Oh, right. Like, how do you actually build and maintain these incredibly complex machines?
Exactly. And that's where Schneepat really gets into the nitty-gritty. And that's what we'll explore in part 2 of our deep dive. Welcome back to our deep dive into quantum supremacy with Jorgo Schneepat.
So, we left off talking about all the amazing things quantum computers could potentially do.
Right, but Jorgo Schneepat also wants to make sure we're aware of the challenges. Building and maintaining these things is no walk in the park.
Yeah, I imagine it's a bit more complicated than just slapping together some circuits and hitting the go button.
A bit more. One of the biggest hurdles is something called decoherence.
Decoherence. That sounds ominous.
It kind of is. Basically, it's the tendency of those delicate qubits to lose their quantum properties.
So they sort of fall apart.
In a way, yeah. They get disrupted by their surroundings. Things like heat, vibrations, even electromagnetic fields can mess them up.
It's like they have stage fright.
Haha, yeah, kind of. Imagine a qubit in superposition, like that spinning coin we talked about. The slightest nudge can make it collapse into a definite state. Just heads or tails.
When that happens.
Poof. The quantum advantage is gone. So, to combat this, many quantum computers have to operate at super low temperatures.
How low are we talking?
Near absolute zero.
Wow, that's colder than outer space. That must be incredibly difficult and expensive to maintain.
It is. Schneepat even suggests that these extreme conditions could limit how much we can actually scale up quantum computing. It's not just about building bigger machines, it's about creating the right environment for them to work.
So, even if we had a quantum computer the size of this room, keeping it cold enough would be a whole other challenge.
Exactly. And then there's error correction.
Oh, right, because those qubits are so sensitive.
Super sensitive. Even with all the efforts to protect them, they're still prone to errors. Schneepat really highlights the importance of finding ways to compensate for those errors.
Otherwise, the calculations would be unreliable, right?
Exactly. It's like trying to solve a complex math problem when your calculator keeps giving you the wrong answers. It's a tough challenge, but it's crucial if we want to make quantum computing actually useful for solving real-world problems.
So all those amazing applications we talked about, like new medicines and revolutionary materials.
They all depend on being able to control those qubits and keep them stable. We're not quite there yet. Schneepat seems to think we're still in the early days of quantum computing.
So no quantum smartphones anytime soon.
Haha, probably not. But it's exciting to think about the possibilities.
It is. But Schneepat doesn't just focus on the technical stuff, right? He also talks about some bigger questions, like the ethical implications of all this.
Yeah, that's a crucial part of his article. He seems particularly concerned about the potential impact on cybersecurity.
Right, because if a quantum computer could break our current encryption methods,
It could be a huge problem.
it would be like giving hackers the keys to the kingdom.
Exactly. And it's not just about cybersecurity. Schnepphat also raises questions about privacy, even national security. This technology is powerful, and it could be used in a way we haven't even thought of yet.
So it's not all sunshine and roses.
Not exactly. It's important to think about the potential downsides, too. Schnepphat is really pushing us to have a more nuanced conversation about quantum computing, one that goes beyond the hype and the technical details.
Yeah, it's about understanding the impact this technology will have on our lives, on society as a whole. It's not just a scientific endeavor.
Exactly.
So we've talked about the potential of quantum supremacy, the challenges, the ethical concerns. It's a lot to wrap our heads around.
It really is. Yorgo Schnepphat has given us a lot to think about.
He has. As we reach the end of our deep dive into his article, what's the main takeaway you'd want our listeners to remember?
I think Schnepphat does a really good job of capturing this moment in time, you know? We're right on the cusp of something huge.
It's like standing on the edge of a new frontier.
Right.
Full of potential, but also uncertainty.
Yeah, and maybe a little bit of healthy fear, too.
Right. So what's one big question we can leave our listeners with? Something from Schnepphat's article that really got you thinking.
Well, one thing that really resonated with me is Schnepphat's emphasis on the societal impact of quantum computing. He's not just focused on the technology itself, but on how it could change our lives, our world.
Like a ripple effect.
Exactly. He challenges us to think about what happens if this technology keeps advancing at this crazy pace. What ethical dilemmas will we face? What social problems might arise? How do we prepare for a world where quantum computers are everywhere?
It's a big question, and it kind of reminds us that we're not just passive observers in all of this.
Right. We have a responsibility to understand these technologies, to shape how they're developed and used, because ultimately they will shape our future.
Well said. A huge thank you to our expert for walking us through this fascinating and at times mind-boggling topic.
It's been a pleasure.
And to all our listeners, thank you for joining us on this deep dive into quantum supremacy. We hope you found it insightful and maybe even a little bit inspiring.
Keep those brains buzzing.
Exactly. Be sure to check out the show notes for links to learn more. Until next time, keep exploring, keep learning, and keep asking those big questions.